Hello students, hope you all are fine and enjoying this time with your parents. During this time, your studies should not get affected. So here we are, teachers of Vasisht Vidyalaya to help you out. Earlier, we have started our first chapter in chemistry, that is chemical reaction and equation. In this chapter, we have studied how to balance the chemical reaction and few type of chemical reactions, which were combination reaction, decomposition reaction, displacement and double displacement reaction. Now we have more type of chemical reaction, and today we are going to study about oxidation and reduction reaction. Yes, first of all, let's see what is oxidation reaction. In oxidation reaction, if the substance gets oxygen or if it loses hydrogen, it is called oxidation reaction. Yes, a chemical reaction in which a substance either it gets oxygen or it loses hydrogen, we can call that type of reaction as oxidation reaction. I have written one example, one chemical reaction in which you can see this hydrogen gas, it gets oxygen and converts into water. In this, hydrogen gets oxygen and we can call this reaction as oxidation reaction. So I think you are clear now that if a substance is getting oxygen, it is oxidation reaction. Let's see another type, that is reduction reaction. What is reduction reaction first of all? It is just the opposite of oxidation reaction. Yes, if a substance loses oxygen or if it gains hydrogen. A reaction, a chemical reaction, if a substance loses oxygen or it gains hydrogen, we can call these type of reaction as reduction reaction. From this example, you can see copper oxide loses oxygen. We can call that copper oxide is going under reduction reaction. I have written one more example, one more chemical reaction for you. In that you can see manganese oxide is reacting with hydrochloric acid. It gives manganese chloride, water and Cl2, that is chlorine gas. In this reaction, if you see according to our definitions of oxidation and reduction reaction, manganese oxide is using oxygen. We can call this reaction as reduction reaction. Yes, our manganese oxide substance is losing oxygen, so we can call this reaction as reduction reaction. At the same time, hydrochloric acid means hydrogen in that it is getting oxygen, and we can call this reaction as oxidation reaction. Yes. These are oxidation and reduction reaction. I am repeating the definition. Please pay attention. If a substance loses oxygen, it is reduction reaction. If a substance or the atom gain oxygen, it is oxidation reaction. When these two reactions take place together in a chemical reaction, we call them as redox reaction. Yes. It is a redox reaction in which oxidation and reduction reactions, these two reactions take place together. Now in this second equation you can see it is not balanced. And our first topic of this chapter was balancing the chemical reaction. So let's try to balance this reaction. If I write here 4HCl and 2H2O. Now you can see the number of atoms before reaction are equal to the number of atoms after reaction. So this reaction is a balanced chemical redox reaction. Now you know what is a redox reaction. But few terms are there related with redox reaction, and you should know about these terms, because in exam you may get questions like this, that from the given redox reaction identify the oxidized and reduced substance. Now from the equation, if you see zinc oxide is reduced, means it loses oxygen. This zinc oxide undergoes reduction reaction means this substance is getting reduced. And if you see carbon, then carbon is getting oxygen. It means it is undergoing oxidation reaction. And we can say this carbon is oxidized and zinc oxide is reduced. You may get question like this. Identify the oxidizing agent and reducing agent. Now, I can understand oxidized and reduced substance, and with them oxidizing agent and reducing agent. You may get confused with these terms, but trust me, it is very simple to identify which is oxidizing agent. You have to keep in your mind that the substance which always give oxygen to other substance. In this reaction, if you see zinc oxide is giving oxygen, we can say yes, the zinc oxide is oxidizing agent as it is giving oxygen to the carbon. Because of the zinc oxide only, carbon is getting oxygen. So the zinc oxide, the substance which donate its oxygen to other substance, that substance is oxidizing agent. And because of our carbon, because of this carbon atom, zinc oxide is losing its oxygen, so this carbon is reducing agent. In this equation, zinc oxide, no doubt, it undergoes reduction reaction, but actually it behaves as oxidizing agent. And same way, carbon is going under oxidation reaction, but actually it is reducing agent. Because of the carbon, zinc oxide is losing its oxygen atom. Now we are starting with new topic, that is corrosion. You are a little familiar with this word. What do we mean by corrosion? Actually, if the metal get tarnished, if it come in contact with moisture, acids, etc., it get tarnished, the surface of metal get corroded, and that process, it is called corrosion. You must have observed iron articles. When they are very new, they have shiny appearance, but with time they get a reddish brown coating on them. Black coating on silver, green coating on copper. Black coating on silver, green coating on copper, reddish brown coating on iron. These are few examples of corrosion. There is another term related with corrosion, and that is rusting. Wait, don't get confused between corrosion and rusting that they are same. No, they are not. Corrosion is a broad term in which rusting comes. Rusting is related only with iron substances or iron articles. Iron alloys only get rusting, while other metals like silver, copper, or we can say almost all metals, they undergo corrosion. While rusting is a very small term which we use generally for the corrosion of iron. Students, there is one activity given in your textbook that moisture is required for corrosion of iron or rusting of iron. So let's see this activity.
For this experiment, we require 3 test tubes, clean and polished iron nails, tap water, boiled water, anhydrous calcium chloride, rubber stopper, oil and cotton wool. Let's start our experiment. We have taken 3 test tubes and labeled them as A, B and C. In our first test tube A, let's put some anhydrous calcium chloride, clean iron nails. We are covering it with a layer of cotton wool, and we are using a rubber stopper to close the test tube. We are using anhydrous calcium chloride because it absorbs moisture from the air. It acts as a dehydrating agent. In our test tube B, let's put some clean iron nails. We are using boiled water here because it doesn't contain any dissolved gas. Then we are covering it with a layer of oil just to prevent the atmospheric air to come in contact with the water. Let's put rubber stopper. Then in our third test tube, C test tube, Let's put some clean iron nails and we are using tap water. Let's put rubber stopper on it and keep it undisturbed for 3 to 4 days. After 3-4 days, you will observe that in test tube A and B, color of iron nail do not changes while in C it gets rusted because in test tube A, moisture is not available, only air is present, while in B, only water is present, there is no air, while in C, both the conditions which are necessary for rusting are available. These two conditions are air and moisture. So we conclude here that air and moisture are necessary for rusting.
Let's see another example of oxidation reaction in our everyday life, that is rancidity. Have you ever wondered why the chips packet is half full? That is because of this concept rancidity. What is it? Food have oil or fat. When oily or fatty food come in contact with air, with time they oxidized. They react with oxygen. They develops unpleasant smell. They produces rancid substance. On our food material, rancid substance get collected, and because of that, it becomes unsafe for consumption. That is rancidity. Spoilage of food material in which fat and oils are present, they get oxidized, they get rancid, and this process, it is simply called rancidity.
We can prevent rancidity by using antioxidants, vacuum packaging, using nitrogen gas, refrigeration, or protecting it from light.